Hey everyone, in this video we are going to see some of the detailed concepts of Kubernetes. If you are new to this channel, I am Kuet. I make content around DevOps, DevRel and open source ecosystem. So let's get started. This video is in continuation with the KCNA preparation playlist that has been going on, so check out the playlist link from the description to check out the other videos. So now we are at the detailed concept. So this segment consists of detailed bits about important concept that about and components of Kubernetes. So what are the endpoints? So endpoints track IP addresses of the pods assigned to the Kubernetes services. So as I said earlier during the previous videos that the pods have like the dynamic IP addresses allocated to them. Then services are used to make them static so that we can access the pods correctly, so we don't have to remember the IP addresses and stuff for the pods themselves. So what endpoint does is it tracks the IP addresses that are being assigned to Kubernetes services. So the you can check that, and if you have run minikube and stuff, then you can go ahead and run this command and get the what are like the endpoints that are being registered and assigned. So you can check that out here. So you can always check what service is attached to your XYZ pod, like what IP address the service has or your pod has and stuff, and if you can delete a pod and check out the new registry in endpoints as well. So that is the endpoint. So what are endpoint slices? So endpoint slices breaks up the endpoints into smaller manageable segments. Each slice has a limit of 100 pods and essential while solving scaling problems. So what it does it so what essentially is, so let's go to the board so I'm able to explain it in a better way. Okay, so now as I said earlier, like say suppose there is like an endpoint which is like kind of you can say as a database. So here is say suppose service and pod, right? So now there is IP address given here with pod IP address, service IP, pod address, something like that. So now but what if there are thousands and thousands of API endpoints and service and pods are there, right? So what it does is we slice the endpoint. So we slice the endpoints. So now it becomes the collection of endpoints. So it becomes the collection of endpoints and the limit for each is 100. So technically we don't use 100, so I think it is like we assign till 80. So generally it gets assigned as like 80 and 80, something like that, if I am not wrong. And then during scaling it helps. So for scaling, now say suppose you have to scale, so now you just want to create a new slice, that is all. So that's how we do it. Slices helps us with the, it's like a manageable segments, and for like limit of 100 pods for each segment, and it helps us solve the scaling problem. So you might want to take note of this, so that this helps during the solving of like scaling problems. So what is job? So it creates one or more pods, job creates one or more pods and will continue to retry execution of pods until the specified number of them successfully terminate. So it's like we create, so for creating job, it's like create job hello with image and echo hello world, and it will keep on like creating like the pods until it is successfully terminated. So it will with this job it will create a hello kind of pod, I guess, and then it will run keep on running hello world, and if it and will continue running until it terminates. So when it terminates, then the job is done. So it's like one time, if you run it, then it will run. If it terminates, then it's done. So it is similar to that. So this is job. Then but what is cron job? So cron job executes based on repeating schedule. So here we just give do this job, run hello world inside like a pod which has image busybox, and run hello world in it, and job done. But what if you want to do it on schedule? Say suppose create a scenario that your website needs to get updated every weekend, say suppose. How do you do that? You don't want to go there manually, sit on weekends especially and do that. So you can create a cron job, and you can schedule, create a schedule. You don't have to learn this. You can go on Kubernetes documentation and check out different formats, and you can find a correct format for yourself. I think, if I'm not wrong, this is for daily, but check that out once. So it will create a cron job. If you check out, if you just give dash that schedule, then it becomes a cron job. So that might be difference. Think of a question maybe similar to this. So if you give schedule, then it comes here, then image is busybox, and it will do the same. It will echo hello world, and it will keep on repeating according to the schedule. It will keep on doing that. Then what are the selectors? There are three ways of there are three selectors. There is label selector, field selector, and node selector. So as I said earlier, how does namespace know what to select? So say suppose I name my website one pod. So this is the reference to the first video. So if you haven't checked it, please check that out first. So the label selector. So say suppose for all pods. So let's go ahead and check, do that easily. So it would be easier for me as well. So say suppose these are the pods randomly spread across, right? And then these are next bunch of pods in a cluster, and then there are different pods. So now you can understand how chaotic it is, right? So but what if I do is label equals to red, 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 and then similarly label equals to blue, and similarly label equals to yellow. So now what if I have to say delete pods, but it will delete all pods. I just want to delete yellow pods. So what I will do, delete pods, label selector, and label equals to red, so or color equals to yellow, let's say yellow, right? So now what it will do is, okay, so it will not delete everything. That was glitch from my end, but what it will do is, it will say, okay, label is yellow, delete it, 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 label is yellow, delete it. Not only delete, you can group as well. So if you say group all the blue ones in the blue namespace, so what it will do is, it will take, like, say suppose it will I will just remove this from here. So what it will do is, it will take all the blue ones and put it under a namespace. So you can select what pods go under a certain namespace by selecting the label. So every pod with label name blue will go in here. So that's how is label selector works. Field selector, again, different fields and stuff you can select. The name can be a field, etc. Name, CPU usage, not technically CPU usage, but I'm giving you an example. Say suppose the name is there, then say suppose secret. So say suppose, or some pods use certain type of secret, you can select that, all something like that. There are different fields, you can check that out in the Kubernetes documentation. Then node selector, then if you want to put a pod inside only one node, then you can use node selector. So put this node, which node, select a node, so it will select node 1, then it will be put into node 1. So something like that. It's like selecting the node, selecting label, selecting field, selecting node. So there are three types of selectors: label, field, node. Great. So Kuet's object like services and replicas will target pods based on labels. So see, Cubectl get pods, this will get you all the pods, but show labels is equals to give the label, and it will only show you the pods which has these labels. Okay, makes sense? Great. So now what are annotations? So Kubernetes annotations allow you to watch arbitrary non-identifying metadata to objects often used by ingress. So it's like non-identifying metadata is there. If it does not identify inside the cluster, everything is like labels and stuff. But if it is not non-identifying, then you can actually use annotations to make it work or make it identify itself, and it is generally used in ingress. So you can mark this point as important, so often used in ingress annotations. And I will link on again a resource which you can use to understand about more about annotations in the description. Then RPC, so remote procedure call, so it enables programs to communicate with one another on remote machines without knowing it's remote. So it's like there is one program on my computer and I am accessing a program on your computer, but RPC helps the application feel like they are just sitting on just another just another part of your computer. It does not feel like you're contacting to different machines application there. So RPC is a framework of communication in distributed systems. So RPC is used to communicate to establish communication between applications around like distributed systems. So it can be like gRPC is like think of this as a method instead of REST or GraphQL. So kind of API thing. So GraphQL, the gRPC is modern open source high performance RPC, and Kubernetes uses gRPC for pod communication. So for pod communication, what does Kubernetes use? Kubernetes use gRPC for pod communications, right? So that is it, and it's a modern open source high performance RPC. So that's great. Nice. So next is kubelet. So what was one definition of kubelet? It is available on each node, right? Kubelet is available on each node, regardless of control plane or worker node. It is available on each node. It is responsible for pod internal communication via API server. So again, if you want to talk to your anything regarding API server, so kubelet is there, as we saw in like a overview video, I guess. So you can see the like whatever is there. So if you just draw it really quickly, then say suppose this is your control plane, and this is your API server of that is in the control plane, and then there is worker node, and worker node, and worker node, and there is kubelet, and kubelet. So it helps you communicate. So there is like a scheduler, as I said, scheduler. So it want to communicate, it will first talk to API server, then will talk to kubelet. If this node wants to talk to this node, then this will go here, then this will go here, something like that. So kubelet helps you communicate with every other thing using API server. So the communication happens through API server, right? So node agent that runs on all nodes, as I said, it runs on all nodes, and kubelet performs watches pods, configuration on container runtimes is done, pulls images, creates namespaces, runs containers. So everything happening inside, and whatever you are working with, creating pods, the pods are pulling images to run the container, configuring runtimes, watching pods, if some fails, create one and stuff. All these things are done by kubelet. So kubelet is like a captain on a separate captain for the worker node. So it will check, pull, and do all the stuff, and whenever you are working with the pods and stuff, it will go through kubelet, and kubelet will try to help you. Okay, nice. Then there is Cubectl, as we say. Cubectl is command line interface used to communicate with Kubernetes cluster, and which is like command line interface. So it is like, you should remember that Kubectl, then there is command, then there is type, then is name, then flag. For example, Kubectl get, so get would be command, type would be pods. So Kubectl get pods, then we specify pod name, which is case sensitive, and then flags, as we said, right? So show label. So if we just go a bit up, then we can see that. So see, Cubectl, this is command, this is type there, and this is a flag. After that you name flag. So get pods, we need all pods, so we just put here pods. So but if you want to get information of specific pod, so we will do Kubectl, then next command would be describe. So here it is describe. See, Kubectl describe pod, then pod name, and flags are options, so different for each command. So if you go deploy, then the flags will be different. So best thing you can be doing is Kubectl get pods -h. If you do -h, then it will be like help. You will get all the flags you can use for the specific command. So this is like a basic one. What you can do is like apply get log describe exec. What are the types? You can get deployments, like you can do stuff with deployments, pods. NS means namespaces, PC means, so this is a issue here. So it is PV. So what PV means? Persistent volume. Persistent PVC means persistent volume claim. You can get secrets. There are multiple like config maps and stuff. This is not the only list. You can check out Kubectl official documentation on Kubernetes docs page, and then name is whatever name you have given to your applications and stuff, and flags are different from each. As we saw, one is show labels, which is for pods, which is one of the labels, which is one of the flags for the pods. There are different ones. Services, again, IP addresses of pods are ephemeral, so that means temporary, hence we need services. So this is one term you should be knowing, which is ephemeral, so which means temporary. So the IP addresses for pods are ephemeral, hence we need services, and I explained about this before in the before video, so that's why we need services. API server exposes a HTTP API that lets end user access different parts of your cluster and external components with one another, and lets you query and manipulate state of API objects in K8s and desired to scale horizontally. So what does all that mean? So you know, as basic HTTP API, right? So if I get /users/ database, say suppose, so I want to get users database, so /admin/database, so I want to get admins database, so that is API, right? So that's what the API server provides, is a HTTP API that any user can use to access different parts of cluster, and even the internal parts of the cluster to talk to each other as well, to access each other, right? And lets you query and manipulate state of API objects. And what are API objects? Or what are K8s objects? K8s objects are nothing but pods, then you can say replica sets, and all these are all objects of K8s. So if you want to manipulate them, you do that with API server. So you can go ahead and check out API server documentation as well. That is just the similar, whatever you do inside a cluster to talk to each other and manipulate the component objects inside the cluster, you do that using API server. And designed to scale horizontally, you might want to make a note of it. And deployment, so the deployment controller can be swapped out with the deployment tools like Argo CD and Jenkins Flux. So if you have already checked out my Argo CD video, you might know what I am talking about. So what the deployment controller is there, which like checks your desired state and current state, something like that, and swaps out things. So you can actually replace your inbuilt deployment control given to you by Kubernetes with Argo CD, Flux, or Jenkins to perform GitOps and stuff, which is possible. So you should be remembering this, that it is possible to replace your deployment controller, right? So replica set, I have explained it again. So here is a way to maintain desired amount of redundant pods to pods guaranteed availability, right? So you want 3 pods to be running at all times. If one pod falls or fails, then a different pod is created and 3 pods are made available to you all the time. So that is it. And then horizontal pod autoscaler can be used to autoscale replica sets. So this is, we will learn about scaling in a bit more depth going ahead, but this is what you should be knowing, that horizontal pod autoscaler can be used to autoscale a replica set. Then going with stateless, I have again explained this in the previous videos, what is stateful. So what is stateless? So replica sets are used for implementing stateless. So replica set are used to implement stateless applications and send requests to any server. It doesn't matter. So say suppose for example you have a pod of front end, right? And there are 100 pods of front end. So it doesn't matter whichever pod you send request to, every pod has same definition, every pod has same application running, so you can access it all the same. And it doesn't matter whatever you access to. But in stateful sets are used for implementing stateful sets. So for stateless you use replica set. For stateful there is a set called stateful set. Stateful set is used for implementing a stateful application, and it stores the session data in the memory of the virtual machine itself. But in stateless we don't save any data anywhere. If the pod dies, data dies with it. But in stateful you save the data in the memory of virtual machine itself. And this is really important differentiation. So if they ask you should be knowing that replica set is implemented for stateless application, and stateful sets are implemented if you want stateful applications. So this is one definition you should be remembering. And then stateful set, its unique name and address is provided, original index number is assigned to each pod, persistent volume is attached. We will learn about persistent volume and stuff again, but remember it. So persistent volume is attached with persistent link from the pod to the storage. So even if the pod fails, the storage is always there. You can connect pods to the storage, and it is stateful. And stateful set will always start in the same order and terminate in reverse order. This is one thing you should be remembering as a definition for stateful set. And that's it for this video. If you like the video, make sure you hit that like button. It really helps support the channel. If you would like to watch such videos, make sure you hit the subscribe button, and I will see you in the next one. Bye.